Welcome to part 5 of this video series that describes building the Stuart Twin Victoria steam engine. In this video I'll be finishing the cylinder assemblies. I left off the last video with one of the steam chests on a cylinder. I completed the other steam chest off camera. This video starts with both steam chests on the cylinders. This photo shows the cylinders with the steam chests on them. I'm quite happy with the progress so far. I have had to correct a few issues as the engine was part built, but things are going okay. The next job was to make the valve rods. This speeded up clip shows a piece of 1/8 inch diameter stainless steel being faced in the lathe. I then turned the stainless rod down to a diameter of 3/32 of an inch for a length of 9/16 of an inch. Next, I rounded the end of the valve rod with a file. I threaded the valve rod with a 5BA thread for a length of 0.5 inches. This thread is where the valve nut screws onto. With the material being stainless steel, I used plenty of tap magic and cleared any chips regularly by turning the die backwards. Next, I cut the valve rod to a length of just over 2 7/16 inches with a hacksaw, faced the valve rod to length in a lathe, and then threaded the end with a 5BA die for a length of 3/16 of an inch. I made the second valve rod using the same process. This photo shows the valve rods installed in the steam chests. I then moved on to the valve nuts. This clip shows me milling one of the nuts to a length of 3/8 of an inch. Since the material was brass, I put the end mill in the Jacob's chuck. I do this often for less precision or softer materials. This clip shows me tapping one of the valve nuts with a 5BA tap after marking out, center punching with the optical center punch, center drilling, and drilling with a number 37 drill. The slide valves came pre-machined, but before installing them, I polished the valve faces on 800 grit wet and dry using oil as a lubricant. I used a figure of 8 motion to ensure an even polish on the valve face. This photo shows the valve nuts and slide valves installed in the steam chests. I made the glands from a piece of oval gunmetal bar stock that I ordered from Stuart Models. Making the blanks was a straightforward drilling and parting job. I drilled the glands with a number 5 drill, which is tapping size for 1/4 40 threads per inch thread. I then parted the blanks off to a length of 3/16 of an inch. To make the spigot on the gland, I made a mandrel that held the blank while I turned down the thickness of the gland to 1/8 of an inch. This resulted in a 1/16 of an inch spigot on the gland. This clip shows the process of machining the spigot and the gland to thickness. This photo shows one of the finished glands on the bench. The gland has been drilled with 7 BA clearance holes that are used to secure the gland onto the cylinder. There are 4 glands in total. 2 are mounted on the steam chest covers as steam inlets, and the other 2 are mounted on the cylinders as steam outlets. I did not tap threads in the glands at this stage as I am thinking about the best way to make the connecting pipe work up. I'll tap the threads later if I decide to go this route. I machined the gland followers from the same oval bar stock. Again, this was a straightforward drilling, turning and parting job. This clip shows countersinking the end of one of the gland followers. The countersink will compress the gland packing onto the piston rod to seal it. Next, I drilled 2 holes in the gland follower with a number 36 drill, which is clearance size for 7 BA. These holes allow the follower to slide over the studs that are used to tighten the gland follower down to the cylinder cover. This clip shows me drilling one of the holes after center drilling. This photo shows one of the gland followers on the bench. 2 gland followers were made for piston rod glands and another 2 were for the valve rod glands. I made the remaining followers off camera. During assembly of the steam chests and covers, I realized that the steam chests had not been machined to the correct height. The total height of the steam chests was supposed to be 7/16 of an inch, however, the actual height was around ½ an inch. As a first step, I checked the distance between the cylinder port face and the center of the cylinder bore with a height gauge set at 7/8 of an inch. The height was accurate on both cylinders. Next, I checked the distance between the center of the valve rod and the bottom face of a steam chest using a depth gauge and a gauge pin inserted in the hole that locates the valve rod in the steam chest. The depth I was looking for was 0.200 inches, which would be a 1/4 of an inch to the center of the locating hole, as I had a 0.1 inch gauge pin inserted. The reading on the depth gauge showed 0.233 inches, indicating that 0.033 inches needed milling off the steam chest. This clip shows me milling the face of the steam chest to remove the 0.033 inches excess from it. This photo shows me rechecking the depth from the steam chest face to the gauge pin. The measurement of 200,000ths of an inch was correct, as this would give a 1/4 of an inch to the center of the hole the valve rod inserts into. I repeated this process for both steam chests so that I had a 1/4 of an inch from the bottoms of the steam chests to the center of the valve rod locating holes, and 3/16 of an inch from the tops of the steam chests to the center of the valve rod locating holes. After adjusting the steam chests, I rebuilt the cylinder assemblies. This photo shows the completed cylinders on the bench. There was quite a lot of work to complete the cylinders, hence the length of this video. I'll leave this video here as this stage of the build is now complete. So, that's the cylinder assemblies finished. In the next video I'll be moving on to the sole plates. Thank you for watching this video. Please like and subscribe to support my channel. Thank you.